Hi, my name is John Helfin. I'm the Student Expert Program Manager here at Autodesk for the Americas. And today I wanted to go over how to put things together in Inventor. I've shown how to do part modeling. I've shown how to do dynamic simulation and other things. And I've had some requests on my YouTube channel to show how to put things together, explain assembly constraints a little bit. So that's what this video is about. What you see on the screen is my trusty trebuchet, which if you've seen some of my other demos is one of the models I use pretty consistently because it's simple, it does a lot of things, and it's fun to play with. So anyway, what I've done as part of the demos and workshops that I do with students around the country is I've got the assembly all set up where it's assembled, and then I have another version of it where it's laid out on that you can see here that's laid out as a kit of parts, and I have one where the assembly is partly built so that, you know, depending on my time, I can adjust the amount of time it'll take to finish this model. So what we're going to go through today is considered a bottom-up approach to assembly modeling. The other option would be a top-down. So bottom up means essentially that you've built all the parts and now you've got them complete and you're going to put them all together in an assembly. To be honest, typically I don't start this way unless I'm really trying to explain things to people. I normally work with a top-down approach, and I build an assembly. I might build one or two parts on their own and then put them in the assembly and use them as the foundation. For example, in this model, I would have built this ground plane because it is the base that everything attaches to. From there, I would build parts in context of the assembly rather than building them separately and adding them in. But I'll show you how to do both a little bit. I'll touch a little bit of each of those. But I'm not going to really go into too much top-down modeling. Anyway, to get started, what is assembly modeling? Assembly modeling is essentially putting together your assembly. What that means is right now, if you go to the View tab in Inventor, under the Visibility panel, there's a Degrees of Freedom button. What that does is it lets you see the visibility, or turns on the visibility of the degrees of freedom. Every part has 6 degrees of freedom. It has an X, a Y, and a Z translation, and then it's got an X, Y, and Z rotation. In order to properly, fully constrain a 3D model, you have to provide 3 constraints to lock it into place. So I'm going to start with this piece here, which is one of the A-arm components. And I'm going to turn off the degrees of freedom. Just, you can toggle it on and off. So I'll be toggling it back and forth throughout the demonstration, you know, until everybody kind of gets a feel for what it's doing. And then I'll move on to, I'll stop using it. So anyway, if you go back to the Assemble tab in Inventor, in the Position panel, there are 2 things that are important here when you're talking about assembly constraints. One is the constraint dialog box, and one is the assemble command. I typically teach students to start with a constraint dialog. It's considered the old-fashioned way. It's a little bit. It's been in Inventor for forever. It has been the way that you've done assembly constraints up until 2012, maybe 2011. I can't remember when they added the assemble command, but within the last 2 releases, they added the assemble command. And I'll touch base on that in a little bit. But the reason I have people start with the place constraint dialog box is it's good information. It shows the icons. You can hover over them and you can see that this is the mate. You can hover over this and see that it's angle. It's important to understand what these icons look like, what they mean, and what they represent, and understand what the solution options are before you start using the assemble. The assemble command is more for somebody who has a little bit more experience. But once you get that experience using the constraint dialog, the assemble command is really nice. It speeds things up and it makes it a lot easier to assemble things. So anyway, back to getting started. I brought up the assemble, or the constraint dialog box. It defaults to mate, and to be honest, a mate is what you're going to do the majority of the time. So that's the reason it's the default. But you have the mate as your type of constraint. You have your options. You're going to have to pick 2 things that you're going to mate together. So you've got 2 different selection sets here. You can choose to offset those, and I'll talk about that a little bit, just to show you what it does. And then you have a couple of solution options. So we don't have in Inventor a mate and a flush constraint. I mean, technically we do, but essentially what they are just opposites of each other. A mate puts two faces together, and a flush aligns two faces in a flat orientation. So I'll show you this in a second as we do this. Let's go ahead and start out. I'm going to zoom in so that I can very easily select this face. What I'm going to do is I'm going to select to make this face, and let me zoom out, and the side of this plate. Actually, I'm going to turn on my edges just to make it a little bit more clear. There we go. Here you can see what I did is I selected two, and I've got this little, in the dialog box, these little glasses are a preview. So it'll show you what's going to happen. So you can see I've got OK, cancel, and apply all available to me. If I have hit cancel, that part is going to flip back into its original position and everything's going to be canceled. Or I can apply it and move on and start adding new constraints. But before I move forward, let me explain what happened here. So what I did is I selected the two faces, this face here and the side of this ground plane, and it mated them. That's what this solution is. If you hover over this, it says mate. The other option is a flush. It's essentially flips that over. It's just a matter of flipping over the answer, right? So they're very similar constraints, and that's why we only have one. It's called mate, and the solution is a mate or a flush. So what I did is I did a flush, and I'm using this, I'll show you in a second. I'm using this as a temporary kind of constraint just to start getting this one main piece put onto this plate the way I want it. And then I'm going to ground it, and I'm going to build from there, and I'll explain it as I go along. So I'm going to go ahead and hit apply. I'm actually going to hit cancel so I can show you what actually just happened. So if I go to a front view, let me get out of my perspective view so you can see what that looks like. You can see here that these two faces now are aligned. If I zoom in, here's the ground plane and here's the A-arm, and you can see that they're flush in on that face. And the way to test it is I can click and drag I can click any part in Inventor and drag it to see what degrees of freedom it has remaining. So if you'll notice, if I drag to up and down, it slides. If I drag right and left, it does not move. It moves up and down still just because my cursor is moving, but it maintains that flush relationship. So now that I've got that in place, let's go and rotate around here. Next, I'm going to go ahead and move this up a little bit. Okay, so I'm just showing you that even though I'm moving it around, it's still aligned flush to that edge. So now what I'm going to do is I'm going to bring my constraint dialog back up, and now I'm going to use this tangent option. Now this is an option you probably won't use very often. It just so happens that this has, I need it in this case, but I'm going to select a circular edge and then the top of that flat plate. I'm going to zoom out, and you'll see here that it has made that tangent to that edge. Again, this has another option where you can flip, inside or outside of the surface. So again, this is common across all of them for the most part, that you might have a couple different solution options. So it doesn't hurt to switch back and forth between these just to get a feel for what things look like and how it works. So I'm going to hit OK, and now I'll show you what I did. So see, now it's maintaining that tangent if I click and drag, and so I can rotate this up to be, I want to end up with this something like this. And of course, this edge is going to be this face is going to be tangent to the top of the plate. So that's what we're going to do next. But now what you can see is if you look at it from the left, even if I'm dragging this, I'm trying to move it up, it locks that into position, and it's kind of floating in space. But that's what we want it to do. So I'm going to go ahead and go back to my isometric view. And let's add that final constraint here. So I'm going to bring my constraint back up. I'm going to go to my tangent option, and I'm going to select the circular face and the top of the plate. And so now I can slide this back and forth. I can't lift it off the plate because it's maintaining those tangent constraints. And because we have the flush, it's lined up with the side of the model. What I'm going to do now is I don't really want this part right up against the edge. The only reason I put it there was just to explain things and just as a temporary orientation for this. What you'll notice is if I select this part, it highlights in the browser. So here's my A-arm in the browser. Now this is a simple model, so I only have, I don't know, 20 parts or something like that. If you've got 100,000 parts or 50,000 parts in this assembly, this arm may end up dropping off the bottom of the screen and you might not be able to find it. If that happens, you can always right-click on a part and say Find in Browser. So here, actually, let me do that again. Let me pick this projectile just so something else is selected. If I hover over it, it highlights. But if I right click on it and select Find in Browser, oops, I guess I have to select it first. There we go. And then hit Find in Browser, it will find it. And it's a bad example because of the size of this assembly. But the key is it'll scroll the browser to that location, highlight the part for you. You can also do it in reverse. If you don't know where the part is in the assembly, but you need to find it, you can right click and say Find in Window. And it will highlight the part and zoom in on it in the window. So it's just a tip that comes in very handy when you get working with larger assemblies. So next what I'm going to do is suppress this flush constraint because I don't really need it. I just needed it temporarily to align things. I could delete it, but just in case I want to turn it back on, you do have the ability to suppress that. So what that means is you'll notice that it grays out in the browser. That means this constraint is turned off, essentially. So I can now move this model kind of out into the center of this part where I think I'm going to want to build from. If I ever want to go back and put that back on, I can right click on it, on that constraint, and hit unsuppress or uncheck suppress, and you'll notice it snaps back into place. So it's just turning on and off the constraints. All right, so now that I have this part into the position where I want to build or start building the rest of the model, the other thing I'm going to do here is I'm going to ground it. So I select the part and right click. I can select grounded. And you'll notice that in the browser you get a little pin icon next to your part. And if you click and drag, you'll get the little pin icon here as well saying no go. It's an indication that it's grounded. Again, just like any other part, you can go and unground it again if you want. So from time to time you'll ground things and unground things just to help with the assembly process. So next, what I wanted to do is I'm gonna do a couple of things to prep for later. I actually am going to delete this part. Whoops, let me select that part. Let me try this again. I want to delete that part. There we go. And I'm going to delete a few of these screws, just so I can show you something in a little bit here as we go along. Because right now what you're seeing is all these parts in the assembly. In a typical environment where you're not starting with all the parts in a file already, you would use this place button in the upper left-hand corner to select a file from your hard drive. And you know what? Let me see. This is the weight arm. I'm going to go ahead and delete that as well. So I'm going to go back and show you how to place parts in a few different ways as we move along. But first, just to kind of clean things up and get started, let's next look at putting this shaft into position up here. This part is still grounded, so I'm going to bring up my constraint dialog box. And I'm on the mate command already. So I'm going to select the bottom face of this, or the face on the end and the face of this part, and I want them mated as opposed to flush. So I'm going to hit apply, and you'll see it locks that thing into position. So now I can click and drag, but it's maintaining that mate constraint. So even if I click and drag, it's keeping it in position. So essentially all we're doing is working through a process of removing degrees of freedom. Again, remember on the View tab, there is degrees of freedom, and you'll notice that this one does not have the ability, it lost an arrow. I don't know what arrow, it might be the X arrow. I think it's the X direction. Yeah, it's in the X direction, it does not have an arrow any longer. And as I go back to assemble and add a constraint, you'll see these change as we go. So I'm going to do mate. Now, instead of a face here, I'm going to select the axis. So if I hover over this, it by default picks up the axis first. I could, now there you see the select other. That's actually a good thing to show now. So if I just hold my cursor in one place, I'll get what's called the select other dialog. And it gives me the option to select the axis or the face. And this will come in handy. I'll show this a little bit later, a little more. But if you don't want to wait for it, you can right click and say select other, and it brings that dialog box up immediately. So I'm going to select the axis because I want to mate that axis with the axis in this hole. And by doing that, I lock that into position, and you'll notice the degrees of freedom changes. Now the only thing it can do is rotate, which is hard to see because this. If I rotate, you can see the threads in that hole actually spinning a little bit. But essentially, it's locked into place on the axis and on this face, so it can spin. And I'm going to just leave it like that for now. That doesn't really matter in this case. But I'm going to turn off those degrees of freedom again. So next what we want to do is we need to put another AM arm on this side of this model. And I deleted the one that was in this assembly. And the reason I did that is I just wanted to show you that this is essentially just the same part flipped over on the other side. So once you have parts in the assembly, I have this part, I selected it, and here it is in the browser. Rather than having to go back and place and click the place button and browse to my hard drive and select that part, I can actually drag and drop it right from the browser. So if I left click and drag, you'll see I get the little place symbol. And when I release, it puts a copy of that into the assembly. And you can see that down here. Now arm 3 is down here on the bottom. You can reorder things if you need to, just if you want to keep your parts, similar parts in proper orientation with each other in the browser. And now I'm ready to start adding constraints to that part. So I'm going to bring up my constraint dialog box. Now I'm going to use my select other. Select other. It automatically, what select other does, and I'll explain it a little bit more as we go, is it just takes an arrow and shoots it straight through the part. So here I'm selecting the top face. The only other face I could select if I went directly straight through the part into the back of the screen would be the back face. So if I right click and hit select other, whoops, I'm in a bad place. There we go. If I right click and say select other, it automatically picks the bottom face for me without having to rotate. That'll come in more handy when you see some of these other parts down here, but it makes it so you don't have to rotate the model all over the place to get to a face that you can't see. Next, I'm going to select the side face of this part, hit apply, and now my part snaps into place. And again, I can test just to see, make sure it's working, to see, when you're learning, I highly recommend clicking and dragging often just to make sure things are reacting the way you would expect them to. As you get the hang of constraints. All right, so next I'm going to go on a mate. I'm going to select the axis for that hole and the axis to this hole and apply it. Then I'm going to select the axis of this hole and the axis of this hole and apply it. Now what I've done is I've locked this into place, and when I click and drag, you'll notice now I get a no-go symbol, like the no movement. It's different than the grounded one. See over here, if I click this and ground it, I get the pin with the ground symbol. This one is locked into place and cannot move because it's specifically grounded, right? It's been pinned into place. This one, the no-go symbol or the no movement symbol, is actually showing that it's not grounded, but it has enough constraints that it is positioned 100% and it can't move without other parts moving with it or causing it to move. So really this is just a process of rinse and repeat now. Right, let's get down here to put these pieces on. So these are the braces that run between these two holes on the inside. And it has a little boss on the end so that these screws can screw into it a little bit easier. So what I'm going to do is, here's a good example of when you can use the select other. And this is a good example. So I want to get to the bottom face of this, not the top face, but its opposite, underneath this part. But I don't want to move it. I don't want to rotate it. This is where you could use select other. So I'm going to right click and hit select other. So I'm going to hover. Well, first you want to make sure you hover over the face that you think you can get to the bottom face through. And I'll just hover and let it bring up the dialog box. Now, if I click the drop down, you'll see there's 4 faces that I could pick. The top of this face, the top of the ground, the bottom of this face, and the bottom of the ground. And you'll notice in the upper, you can kind of see it up here. It'll highlight that face. Just it's a little hard to see. Let me reposition this so you can see it a little more clearly. There. Whoops. There we go. Select other. So I've got the bottom face there. Top face of this part, bottom face. Top face of the ground plane, bottom face of the ground plane. So without rotating, I can get to any of those 4 locations. So I'm going to pick this bottom of this part. And then I'm going to link it up to the face on this part. And when I do that, it snaps it into position. And I can cancel and I can drag it around. So it's essentially doing what we've already been doing. We're just rinsing and repeating the process. So next, this is something that's common across all Inventor. If you right click, you can hit at the top of the right click menu is the last command you used. Or if you just hit enter on your keyboard, it'll bring up the last command you're using. This comes in handy when you're using constraints because you're going to keep going into this dialog box. But again, once we get into the assemble command, this will be a lot different. You won't need the dialog box anymore. So I'm going to select that axis and the axis of the hole that I want it aligned with. And now, if I click and drag, you'll notice that I can rotate this. Again, just another way to test, make sure things are working the way you expected them. So I'm going to hit Enter on my keyboard to bring the last command up. I'm going to select this axis and the axis for this hole and apply that, and it locks into place. Now, without even getting out of the dialog box, I'm going to start doing the same process again. Select Other. I'm going to get the bottom face. I'm going to lock that face there, hit Apply. Oh, I must have picked the wrong face. I think I picked the top face of the ground plane, which is grounded. So that's actually not a bad thing. Let me go back and show you what just happened. Because the last thing I want everybody to think is that errors are bad. Errors aren't, that was just a warning telling me that I had tried to do something that the system couldn't do. If I try to take this top face of this ground plane and made it to this part here, I'm going to get that error. And what it says is I can either edit the constraint and pick a different, I could go back to these selection options and select something different. Or I could go back, I could just say cancel this. I could say, go ahead and I say, whoops, I know that this was grounded. Maybe I grounded it temporarily and I didn't mean to. And I know that's what's causing the problem. I could just say, yep, accept that constraint, put it on there in a failed fashion. And then I could go unground this plane and it would snap it into position and it would be like you put on a proper constraint. And then there's also a diagnose process that you can go in and suppress constraints and walk through a process to try to fix it. But in most cases, once you get the hang of it, you'll know what's going on. For example, if two parts are assembled in a way that they can't complete the constraint. So for example, I've got this shaft here that defines the distance between these two parts. Down here, I've got another part that I'm going to put in between here again in a little bit. But it's shorter than this one. So it can't mate this face in this face, in the back face of this part, because this one's longer, and it would cause a failure there. So there's going to be little failures that happen, depending on how you've designed your parts. But these are all things that are, it's not the end of the world. So you just get some practice with it and you'll realize that it's not that difficult. So I'm going to go back and continue where I was. I'm going to select the bottom of that face and the back of this face. I'm going to apply that constraint. And then I'm going to zoom in a little bit and get that axis and the axis of this hole and apply that. Let me zoom out a bit. You can see it's hanging down underneath, so I'm going to cancel this. You can click and drag and it rotates into place. And this, you don't have to do that. I'm just doing it just for visibility purposes so you can kind of see what's going on. So I'm going to hit Enter on my keyboard and bring the constraint dialog box back up. I'm going to do that axis and the axis to this hole. Now you'll notice I'm going to go back and I'm going to reselect the second selection. I could pick the center of this hole or the outer face. It's up to you how you do it. If you know that this hole is always going to be concentric with this face, it really doesn't matter which one you pick. It's a matter of preference. To be 100% safe, you should probably pick the center of the holes because you know those are the things that you want lined up. But again, it really is a matter of design intent. So I'm going to select the center of that hole and hit OK. And now I have those parts locked into place. Let me zoom out a bit. Let me kind of reset everything back to where I was. Okay, so now I've got everything kind of in position. It's the frame starting to come together. Everything's locking into position because this is grounded and everything's constrained to it. Next, let's go ahead and put in this piece here. It works pretty much the same way with one slight difference. I'm going to go ahead and select that face and apply. I'm going to select that axis and the axis for this hole and apply. Now, the one thing you'll see here is this does rotate, right? So it does have a degree of freedom remaining. Now, it may or may not make sense to put a constraint on there to prevent that from rotating. I know when I assemble this, though, the pressure from these screws that are holding this together and the way this assembles, this is not going to rotate like this. So I'm going to go ahead and add one more constraint to remove its final degree of freedom. And that's going to be an angle constraint. We haven't done this one yet, so I'll show it to you. I'm going to select the angle constraint. It's pretty simple. I'm going to select the top face there and any other face that I want it aligned with. And I want those to be in the same orientation with 0 degrees of angle between the two. I'm going to select the directed angle option, and I'm not going to get into these options. They get a little more advanced as you need them. Just remember, there's alternate solutions for all constraints. So if you need to, something's not working for you exactly right, look at these other solutions, and the help file does explain these, but I'm not going to get into them now. So what I can do is let me show you here. If I hit 0 and hit apply, it's going to lock that into place. So this angle, this face and this face have 0 degrees of distance or angle between them. They're parallel to each other. Now, if I select this and I say find in browser, there it is right here, the trigger plate. What you'll notice is that as I've been adding these constraints, it's been adding them underneath each of the parts. So it's going to have, this is another thing that comes in handy to know about. If you need to know where the other half of this constraint is, it's kind of like find in browser. This has another face. This is the face on the trigger plate. And you can also see when I highlighted this, it's showing me the other face that's involved. But I don't know exactly what part that is. I mean, I can hover over it here and I see it's the base link. But I could also right click on it and say find other half, or here it is, it's called other half. And it will jump to that part and expand it and highlight the other half of that constraint. Comes in handy just for finding constraints and doing some troubleshooting if you get a little too far down a path where things aren't assembling properly and you have to troubleshoot things. The other thing you'll notice is this angle. So the angle is important, or the reason I wanted to show you a little bit more about the angle is it shows you the degrees. In the dialog box, if I right click on this and hit edit, you'll see this degree, right? If I say 45 and then I hit OK, now you'll notice this face and this face are 45 degrees apart, right? So it's just controlling the angle. The same goes for mates in any of our other constraints. I'll show you that in a better example in a little bit. But one of the shortcuts you can do is if I select this angle, you'll notice down at the bottom of the browser, there's a quick input area where I can say, well, let's see what 78 degrees looks like. And when I change it, you'll notice that it changed it to 70 degrees. So I'm going to go ahead and set that back to 0. And all I'm doing is typing 0 and hitting enter on the keyboard. It resets it. So that's just something that you can, it does come in handy from time to time. And it actually controls drive constraints, which I'm not going to get into here. But I'll do, just because we're in assemblies and I've got a couple parts that are easy to work with, I'm going to do a quick side tangent run here on drive constraints because it's important to know, and it comes in very handy showing motion and examples for people who need to see your models. I'm going to really quickly set up a drive constraint, and it really is nothing special. It's just a constraint, and you're changing the distance of the offset in an animated fashion. So for example, I'm going to take this part, I'm going to bring up my constraint, and I'm just going to make the face of this arm to the top of the ground plane. And I'm going to apply it. Notice that there's 0 offset. If I set this to 1 inch, you can see that it changes. Here's 0.5, and then let's go back to 0. So all you're doing is, I've created a mate constraint. Now let me find that in the browser. I have the projectile arm. Here's my mate. On any constraint that has an offset like that, you can right click on it and select to drive that constraint. Let me bring the dialog box in here. So what this is going to do is it's going to say start at 0 inches, which is where it's at now. This constraint is 0 inches off. It has no offset at all. And then I'm going to say make it, let's do 3 inches. I'm going to do between 0 offset and 3 inches of offset with no delay. And this little double arrow is just more options that you can run. One of the options is just go from the start position to the end position. That's it. The other option here under repetitions is start, end, start. So I'm going to go from the start to the end and back to the start once. In this case, I'm going to do it 3 times. The other options here are the amount of steps. So if you did it in 1 inch increments for 3 inches, this would make 3 steps to get there. I'm actually going to do it in let's do 0.1 inch steps. You could also choose to do it in the number of steps. You could say do it in 30 steps. And you'll have to play with these just to see. But I'm going to go back to 0.1, and I'm just going to hit play. And all it's doing is changing that offset value for me. And actually, you know what? I'm going to go to, let's do 0.05 instead and play that again. So by doing smaller increments, it does slower motion. Or if you want to see it do things more, longer, you could maybe make it 5 inches, 0 inches to 5 inches, and maybe make it do 5 times back and forth. So you'll notice in the top of this dialog box, it's running and it's giving you the distance of offset. It's just handy to kind of see. You can also stop this at any point and see what that is. So you could put that offset in if you know where that's, you could lock it in at that position. So if I hit OK here, well, let me go a little bit. Oops. There. Okay, so what I did is I stopped it at about 1.6 inches. Well, exactly 1.6 inches. If I hit OK, what it did was it put the offset value in for 1.6. It's just like I went and typed it here. So it's just a way you could do some testing. You could find a value that worked, and you could apply it quickly to your model. Or if you decide that you don't want it anymore, you just go back and hit 0 here, and you're back to where you started with no harm, no foul. So I'm going to go ahead and delete that constraint. Sorry for the little, side run there and the tangent I got off on derived constraints, but they come in very handy. And actually, you know what? Let me undo that. The other important thing to remember here is that if other parts are constrained to that arm, so say for example, let me go and pick the top face of this bolt or this clevis pin. If I were to mate this to the arm here and apply that, now if I do the drive constraint, it keeps those constraints, right? I'm going to drive this mate again. And both parts move. So it does maintain these relationships between those parts, even if you're driving constraints, which again makes it so that you can do all kinds of motion testing and things like that. So anyway, I'm going to undo, put those parts all back to where they were, and we'll continue with our example. Next, what I want to do is put this arm here into the center here. Now, there's a couple of things that are going to happen here. So that we can talk about. So I'm going to select this part in the browser or in the graphics window, and it highlights in the browser. If I expand this, you got to remember back to the part modeling examples, every part has X, Y, and Z planes and axes. When I created this part, I used a symmetric extrude. So I know that the XZ plane here runs right through the middle of this part. And if I zoom in, you can see it. It extruded a 1/4 inch or an 1/8 inch in one direction and 1/8 inch in another direction. So I know that this part is exactly centered on that XZ plane. Now this is important. It comes in handy. It's again a tip and trick that is useful to know. If you have something like this selected in the browser and you start the command, you'll notice that selection 1 has already been made and it's asking you for selection 2. So that's good to know that it's bidirectional and it allows you to pre-select things just to, it makes it a little bit easier. Once you get the hang of it, it really speeds things up. But the other thing that we need here is this part here. We find it in the browser. There it is. The A-arm shaft also has origin planes, but in this case, I did not use a symmetric extrude. So what I need to do is I need to add a plane right in the center of this part that's always going to remain in the center of this part. So what I'm going to do is this is where we get into a little bit of top-down assembly modeling, where I already have an assembly and I can go make changes to the model as part of a way to assemble things. So I'm just going to double-click this part. Now, one of the things you can do is I could go and I could say, here's mid-plane between two planes. I could select this specifically. And there's a bunch of different options for creating work planes that you can do. I almost never use this drop-down list. It's good when you're learning, right, in the beginning, to understand what options are available. But once you have a feel for what they do, you can just click this plane button. And I know that once I select this face, I have the ability to select another face. And I know just from practice and just trying things out that when I select this other face, it's going to create a plane right in the middle. And it shows you the preview for it. It's hard to see here but you can see when I move away, I'm getting the plane on this face that I'm selecting, and it's showing me the plane that's going to create right here in the middle. So when I select that, I get a plane right in the middle. If these planes move apart, this will always be centered between these two. So that comes in handy when we're starting to do some modeling. And I can go back to my assembly with the return button in the upper corner, and I'm back in the assembly right where I was, but now I have a work plane that I can use for mating these two parts together. So let me go find this in the browser again. There we go. And here's my XZ plane. I'm going to select that, and then I'm going to hit Constraint. And so my first selection's already been made, and I'm going to select this work plane that we just created, and I'm going to apply that. Now, one thing I kind of screwed up there, which is not the end of the world. Again, you're going to run into issues, not issues, but places where you maybe clicked apply too quickly or whatnot. You can always go back to the browser and right click on a constraint and hit edit. One thing is I don't like this flat plane on this side. I want it flipped over. So I really wanted the flush constraint, not the mate. So I'm going to hit the flush solution and hit OK. And all it did was flip that part over just so I can see these indentions and things like that. It's more for aesthetics than anything. But now I'm going to hit enter on my keyboard and get back into the constraint dialog box. I'm going to select this axis and the axis of the part or the shaft. And when I hit OK, it locks it into place, and you can see that it can rotate now. So what I'm doing is I'm just starting to assemble it just like you would get a kit of parts and start putting things together. It works the same way here. So now what I want to do is show you a little bit more about the assemble constraint. You've kind of seen all this dialog box stuff and mates and flushes and offsets. The assemble command does something a little bit different. What it does is let me get in and I'll show you. It brings up a heads up display. Here's your offset, same thing you had in the dialog box before. It has a drop down here where you could select mate, flush, and these are the different solutions for mate. Here's an angle directed, here's tangent, outside and inside. So these are those solutions that you can have for those. And what it does is I'm going to start with, let's zoom in a little bit. Let's start with this face. When you select a face, it starts looking for things you can solve to, things you can mate to. So what I'm going to do here is I'm going to rotate around, and I think this is the right way. I'm going to select this face. Yep, that's right. Okay, and now what it does is it brings up the plus symbol, the undo, and the accept option, or OK. I'm going to temporarily apply this. The plus symbol says, yep, I like that constraint. Go ahead and apply it temporarily. If I were to hit escape, everything would just cancel and go back to where it was. But what it's letting me do is rather than keep hitting apply and launching the dialog and apply and launching the dialog box, it's letting me, whoops, well here, I'll show you what escape does because I picked the wrong thing. Oh no, it let me drop out, okay. Here, let me hit escape and get back to, what it did was apply, I hit the wrong button there and it applied that constraint, but it has not applied the axis constraint that I was getting ready to apply. So let me hit enter again, get back into my assemble command. I'm going to right click and hit select other. I want this axis. And now it's going to start looking for points or axes or things that I can mate to. And I'm going to select that. Let me do the center of that hole. Now you'll notice I can actually select, it doesn't select anything on the part that I have chosen to start with. So it's really like selecting through that part into that hole. So I'm going to select that and I'm going to hit apply. And now you'll see these two things are locked together. And I can start to position it in a way that would make sense. And if you've seen my other assembly or dynamic simulations, you'll see that this arm is supposed to be flipped under because we're going to put the weight up here and it's going to throw a projectile. So anyway, now that we've got that position, that arm into place, I'm going to show you the assemble command in a minute again. But one of the things I did was I deleted the weight that hangs on this end piece. So I'm going to show you the place constraint or the place dialog just so you can see the process, but it's pretty simple. I'm going to go scroll down through my work and find that, or through my list of parts and find my weight arm. And I'm going to select that. And it just asks me where I want to place it. And I can place it anywhere. And once I've placed it, if I want multiples, I could click it again and place another version of it. When you're done, just right click and hit done or hit escape on your keyboard. Now I placed two and I don't need them. So I'm going to select this one and I'm going to right click and just hit delete. So I have the piece I need. Now I'm going to go back into the assemble command. I'm going to assemble this face to this face. I'm going to temporarily apply that, and it's upside down, which is no big deal. I'm going to select other, and I'm going to get the axis for this place, or this weight, and I'm going to select the axis for that hole. And now that I've got two applied, I'm going to hit OK, and now I have the ability to, well, here's a place where occasionally you might want to ground things. When you start linking lots of parts together, things get a little out of whack or can if you're not careful. So you might select this part and ground it to give more predictable motion, right? So I know that I can flip this around now. I can get this part and move it, and it will, I can position it roughly where I want. And I can always go back and unground that part. Right, so there's now motion between those. Okay. All right, so now what we'll do is we'll add a few more constraints just to finish this off. And I'm going to use the assemble constraint quite a bit here. And I'll move along a little bit faster now. I'm going to hit assemble. If you select the circular edge of a part, you get an arrow pointing down. That's the insert constraint, which we haven't talked about. But what it does is it aligns a face and an axis at the same time. So it mounts the bottom face of this stopper to the top face of this part, and the axis of this hole to the axis of the threaded hole that we just attached to. So it's kind of a shortcut. It comes in handy for putting nuts and bolts and screws together. Now I'm going to zoom in and pick this face there to insert that into that hole. And again, let me rotate around. If I get the right angle here, I can see all these holes and I can see all these screws. So now I can do assemble. And I can do that face and that face. Okay, I'm going to hit enter on my keyboard to get back into it. That face and that face. I'm going to hit enter on my keyboard, and that face and that face. So now I've got all three of those parts. So what I did was with the insert constraint, now if I click and drag, you can see it spins, which is what it's supposed to do, but it can't come out of the hole. Now those little icons that are coming up, those are called iMates. All our fasteners and things like that in our libraries have iMates. They're half of one constraint. And I'm not going to get into that here, but I could hold control down. If I zoom in, this is a mate, this is a mate, and this is an insert. So if I have this part just laying in an assembly, I could hold control down and drag that, and it would snap into position automatically. But again, I'm not going to get into that into this example. All right, so real quick, now we're going to do assemble, and we will put that clevis pin into that hole. And we'll hit enter on our keyboard. We'll put this clevis pin. Now, while I'm moving this around, what I'm doing to reposition is I'm just clicking my middle mouse button and panning. I can also scroll my middle mouse button to zoom. So while I'm in the middle of the command, you can use those. It makes it a little easier to get around. So now I have those clevis pins in position. Now I need these pins to hold those into place. So what I'm going to do is enter on my keyboard to get the assemble constraint again. I'm going to select other to get the axis. And then I'm going to rotate around here, and I'm going to put that through the axis of that hole. Now I'm going to temporarily apply that because I have one more constraint I want to do here. I want to right click on that and select other, and I want to get the axis for that hole, that rounded piece of the pin, and line it up with the pin itself. And now I can apply both of those constraints at once. And now you'll notice when I spin this, the pin spins with it because they're linked, like they're snapped together. Okay, so let's do the same thing on the other side. With this pin, I'm going to hit enter to get back into the command I was just using. I'm going to select other and get the axis. Whoop. Let me zoom out a bit. Oh, I forgot it's on the other side, so I'm going to rotate around. Sorry for the quick motion there. I'm going to get that axis. I'm going to temporarily apply it with the plus symbol. I'm going to select other on to get the axis of that pin and snap it to the center of the clevis pin itself. And then I'm going to hit the checkbox to apply both of those constraints at once. And now, when I click and drag, they all move as one big, huge system. Okay. Last but not least, let's get back to those screws. I had deleted a few of the screws, and I just wanted to get back to this shortcut. Once you've started to do expand all these parts, if you right-click on the top level assembly, you can choose to collapse all children, and it will quickly just collapse everything. Just cleans it up a little bit, so that I can find this. Where it is? These screws. So I'm gonna just click and drag from the browser and put a couple more screws in here. I need 3 more screws to put into these holes. So I'm gonna get into my assemble constraint, select the bottom of that screw, the bottom of the hole, and hit apply. Enter on my keyboard, center of that, to the bottom center of that hole, places that, and one more time enter on the keyboard to get back into the constraint or to the assemble command. And I'll select the circle on the bottom of that hole and apply that. So now these are all locked into place too. Okay. Last but not least, let's go ahead and throw these pins in, these little C-clips in. They fall into this hole. I'm going to temporarily apply that. I'm going to select the center of this, select the axis that goes through the center of that pin, and I'm going to lock it there and hit apply. Whoops, helps if I hit the check button. There we go. Now I'm going to go back out and hit enter again, select this face, rotate around to the other side. Well, I'm just going to use my view cube for that. Whoa. Let's try that again. There we go. Upper corner. And I'm going to select the inside face there. Oh, let me zoom in. There we go. Temporarily apply it with the plus. Then I'm going to select other to get the axis that runs through the center of this pin. And I'll select the center of that. And then hit the checkbox to apply. And now I have all my pieces locked into place. So there you have it. Crash course in assembly modeling. Hopefully that helped everybody. Now that you have this assembled and work, if you haven't seen the dynamic simulation video, it'd be worth going to watch that now, because you can actually see, now that I've assembled it, what you can actually do with it, which is quite a lot actually. So look forward to speaking with everybody again in the future. Hopefully this was helpful. Thanks.